Hello everyone, welcome to all. Welcome to the virtual lab. For this lab, we are going to study for a 10 experiment. The first experiment is characteristics of PN junction diode, and the second experiment is characteristics of Zener diode, and third experiment common emitter input output characteristics, and fourth one common base input output characteristics, and fifth experiment common collector input output characteristics, and sixth experiment FIT characteristics, and seventh one MOSFET characteristics, and eighth one Zener characteristics, and then UJT characteristics, and also HCR characteristics. For this physics lab, we are going to study for 10 experiment. First, initially I have to start for first experiment. The name of the experiment is study of VA characteristics of PN junction diode. And before that, I give a small introduction about PN junction diode. The PN junction diode is formed by a layer of P-type and N-type semiconducting materials. Diode does not conduct, but there will be leakage of current due to the minority carriers. It's formed with a free electron in N region and diffuse across the junction and combine with holes in P region, and so a depletion layer is developed. In one side we are taking for a P-type material, another side we are taking for N-type material. Both are sandwiched. We make a PN junction diode. For this diode, we can combine the P-type material and N-type material. We have to make a PN junction diode. When we are making a PN junction diode, one depletion layer is produced. The depletion layer consists of ions which act like as a barrier for diffusion of charge beyond a certain limit. It means for a germanium material or silicon material, the potential barrier value is varying. For silicon material, is for 0.7 volt. For 0.3 volt for germanium diode. In the PN junction diode, when we form a forward bias, when we are giving a forward bias, the majority carriers acquire for sufficient energy to overcome the barrier, and the diode will be conduct. When we connect in the reverse bias, the depletion layer width will be widened and the barrier potential will be increases. For this experiment, the main aim of this PN junction diode, we can plot the graph for VA characteristics of PN junction diode. What are the apparatus are required? First main thing is a diode. IN4007 I have used it for that. Here we are using for a 4001, and resistance 1K we are using for here. Voltmeter range 0 to 5 volt. Ammeter range 0 to 30 milliampere, and we are using for a power supply also. When we connect for this apparatus, we are using for a breadboard. For this breadboard, we are using for a diode, and we are making for a connecting wire, and we have to make for circuit using a connecting wires. So these are the items are required to determine the VA characteristics of PN junction diode. Basic theory of PN junction diode. See here, the diode is a device to form a junction of N-type and P-type material. See, this is a P-type material and the N-type material. P is a positive, is an anode material, and N is a cathode, is a negative material. This is a negative material. This is P-type material and N-type material. The if connected to the p-type material is called as the anode, and the lead is connected to the n-type material is called as the cathode. In general, the cathode of a diode is marked by a solid line on the diode. The anode, the cathode. So this is a diode symbol, the positive symbol. This is a line for a vertical line is for a cathode. Before we are doing the experiment, we should know about the function of p-n junction diode. See, this is a forward bias characteristics. In this forward bias characteristics, is that the positive is connected to the positive and negative is connected to the negative of the positive. The positive plane, the source of the voltage, and positive is connected to the positive and negative is connected to the negative. The positive terminal of the battery is connected to the p side, that is the anode. The negative terminal of the battery is connected to the n side of the diode, the cathode. The holes in the p-type region and the electrons in the n-type region are pushed towards the junction and to start neutralize the depletion zone. We already discussed that the p-type material and n-type material both are sandwiched. When we make the junction, the depletion layer is produced. See, when we are applying a forward bias, they are pushed towards the junction to start to neutralize the depletion layer and reducing the width. The positive potential is applied to the p-type material, repels the holes, while the negative potential applied to the n-type material repels the electron. The change in the potential between the p side and n side decreases. With increase the forward bias voltage, the depletion zone eventually becomes very thin enough that the zone electric field cannot counteract the charge carrier's motion across the p-n junction. The electron that cross the p-n junction into the p-type material or holes that cross into the n-type material will diffuse into the nearby neutral region. That means the amount of minority diffusion in the neutral zone determines the amount of current that may flow through the diode. So this is called as a forward bias. I understand? See, here the positive is connected to the positive and negative is connected to the negative. Here the positive electrons are flowing in this direction, negative electrons flow in this direction. Okay. So the opposite charges attract each other. We know that, which means it can easily pass through the diode. Electrons are flowing in the opposite direction of the diode. That means it can easily flow. Because of that, the depletion layer width is very thin. This is called as a forward bias. When we have to apply a voltage or increase the voltage, the depletion layer will be reduced. That means the layer will be very thin. It will easily conduct the electron. This is called as a forward bias. And this is for the p-n junction diode for reverse bias. The main function of the reverse bias, the positive terminal of the battery is connected to the n side, there is a cathode, and the negative terminal of the battery is connected to the p side of the diode, there is a anode. Therefore, a very little amount of current will flow until the diode will be broken. The positive terminal of the battery is connected to the n side, and the negative terminal of the battery is connected to the p side of a diode. That means the holes in the p side material are pulled away from the junction. It leaves behind the charged ions and causing the width of the depletion region to increase. So likewise, because of n-type region is connected to the positive terminal, the electron will also pull away from the junction with a similar effect. They increase the voltage barrier, causing a high resistance to flow of charge carriers, thus allowing minimal electric current flow to cross the p-n junction. The increase in the resistance of p-n junction result the junction behaves as an insulator. So that means there is no flow of current between the p-type material and n-type material. So that to strengthen the depletion zone electric field increases, the reverse voltage increases. Once the electric field intensity increases beyond the critical value of the p-n junction depletion zone, breaks down and current begins to flow, usually either the Zener diode or avalanche effect. We already studied in the theory classes. So both of these breakdown process are non-destructive or reversible, as long as the amount of current flowing does not reach the level that cause the semiconducting material to overheat and cause that thermal damage. Because when we increase the voltages, high voltages, the diode will be broken because that depletion area is with is very high. That means it cannot easily flow from P to NT material or N to PT material. So that the depletion will be increases, that means the heat will be produced in the depletion layer. That means it will be broken of the diode. This is called as the reverse bias. It's only applicable for the Xenodiode. And before that, before we are doing the simulation lab or virtual lab, what are the procedures we have to follow for this experiment? First, we have to set DC voltage to 0.2 volt. This is the minimum voltage we are given to the diode. See here, this is a circuit diagram of the circuit diagram of forward bias characteristics of diode. See here, this is the ammeter. We have to measure the current, and the voltmeter. We have to measure the voltage, and this is the source of DC voltage, and we are grounding for here only. And here we are fixing for a resistance. We have to fix for 1K or 1000 ohms. See here, first this is the circuit diagram of the forward bias. See, first we have to select the DC voltage is 0.2 volt, and then we have to select the diode. Diode here we are choosing for IN4001, and then we have to set the resistance value. Then you can vary the value of the voltage. Then we can measure the current value. So we have first, before that we have to follow this instruction. We have to do for a forward bias characteristics, and this is for the reverse bias characteristics. The similar procedure we have to follow for here also, and then the same diagram, but the diode polarity will be changed. See here, this is the negative is connected to the positive. This positive side is connected to the negative of the positive. This is called as the reverse bias. Similarly, we can choose for the DC voltage and diode and the resistance also, and parallelly how to rise for similarly how to write for the voltages and vary the and measure the current values. Then we have to plot the graph, and then further changes are appear for when we increase the voltage and what is the current will be changes. Then we have to measure and take the plot, the graph that is called as the VA characteristics of diode. You can see the demo videos using the link YouTube link. You can see how to do the experiment for characteristics of diode. You can simply click the link, and then you can watch the full demo video of this experiment. And then this is the link for simulation lab for this experiment, and this is for a forward bias link and reverse bias also. Using the link, you can do individually this experiment. Thank you. Thank you very much for watching these videos.